discuss about the problems regarding to laws of motion. State board, from state board syllabus, numerical problem, first one. A force of 50 Newton act on the object of mass 20 kilogram. Shown in this figure. Here this is 20 kilogram mass. Here a force of 50 Newton acting in this direction on this mass 20 kilogram. Calculate the acceleration of the object in x and y direction. Here we have to find the acceleration of this object due to the force acting on the object. The force 50 Newton acting on the object having mass 20 kilogram. So here we have to find out the acceleration along x-axis and acceleration along y-axis. Here let us discuss about the components, x component and y component of the force, because according to Newton's second law of motion, according to Newton's second law of motion, Newton's second law of motion, force is equal to mass into acceleration. Here force is a vector quantity, so it can be resolved into two components. One is along x-axis, another one is y-axis. So here we have to find the acceleration along x-axis and acceleration along y-axis. So the formula becomes, along x-axis, Fx, the force along x-axis Fx is equal to mass into acceleration along x-axis. Here the force and the acceleration are the vector quantities. So both force and acceleration can be resolved into two components. One is x component, another one is y component. Here mass is a scalar quantity, so we cannot resolve into two, either along x-axis or y-axis. So here we have to write Fx is equal to m into ax. So from this problem we have to find the acceleration along x. So the formula becomes ax is equal to Fx divided by m. So now we find the force along x-axis. So you see the now let us draw the another figure. Here this is the mass, and we have to find cos theta. For the same right angle triangle, one side is Fx divided by hypotenuse is f. Here cos theta is equal to Fx divided by f. Here Fx is equal to f into cos theta, and Fy is equal to f sin theta. So these are the two components of the force. Now we substitute the value of Fx in the previous equation. So ax is equal to, the value of Fx is f cos theta divided by m. So from this problem, the value of force is 50 Newton into cos, the angle of the object making an angle with the x-axis is 30 degree. So theta is 30 degree and mass of the object is 20 kilogram. So here 50 cos 30 is root 3 by 2. Root 3 by 2 divided by 20. Here 50, the value of root 3 is 1.732 divided by 2 into here there is another value 20. So 50, the value of root 3 is 1.732. Here 2 and another value 20. By values we get the answer 2.165 meter per second square. So the acceleration of the object along x-axis is 2.165 meter per second square. And now let us find the another value, that is, now let us find the y component of acceleration is ay. Ay is equal to, from the above equation, that is Newton's second law of motion, F is equal to ma. Here Fy is equal to m into ay. So ay is equal to Fy divided by m. So y component of the acceleration, that is, here you see the value Fy is equal to f sin theta. Y component of the force acting on the object is f sin theta. So substitute the value of Fy in this equation, f sin theta divided by m. So ay is equal to, the value of force is 50 into sine the angle of theta is 30 degree divided by mass of the object is 20. So 50 sine 30, value is 1 by 2 divided by 20. By solving these values, we get the answer ay is equal to 1.25 meter per second square. Okay, thank you. This is the object. The force acting along this direction. Here the x component of the force is Fx, that is force acting along x-axis is this one, and another one y component of the force Fy. Here we take this x component and y component. Draw a right angle triangle like this. Here this is right angle triangle. This is F, this side F, and this length, this Fy, and this 2 are equal. So here we put Fy. So this is the y component, this is x component. So Fx, Fy, F. This is right angle. Now we write the sine theta for this right angle triangle. So sine theta is equal to opposite side by hypotenuse. Here opposite side means the angle which is opposite to this the side which is opposite to this theta, that is the force component. Here the opposite side is Fy and hypotenuse is F. So here sine theta is equal to Fy divided by F.